In this section we will discuss about how to use the rviz based on our application and what are the necessary options we have to enable in the rviz to visualize the data. Each and every option we have to see based on your application. So let's begin. First of all, to understand how the rviz is working and how the data is looking in the rviz, so we will launch the gazebo first of all. Next, and rviz you can open in different way by using the launch file, or directly you can type the rviz2. First of all, I will open in the form of a launch file, then you can understand further how to open with the rviz2. This is my launch file. It can open the rviz and it can directly set up my robot in the rviz. Okay, did you understand? All the robot options it already it was inserted. If you want to open the rviz without the launch file, you can directly type like rviz2. See, you can see the difference between the launch file and the I opened only the rviz. Through the launch file it directly set up my rover in this rviz, but without launch file I open only the rviz. Okay, so I will set up one by one and you can see both are looking the same. Okay, here first of all you can keep a based on your situation. If you are doing the mapping, you can keep a map, or you can do the navigation, then also you have to give the map, or you want to see the moving the robot in the gazebo and you have to visualize that in the rviz, you can keep as like a base link or and the odom, like momentum will be shown in the rviz. Okay, so first of all we have to add our robot in the rviz. Here is a display option, robot model. In that robot model you can see the description topic, robot description. Here you can see our robot is visualizing in the rviz, and as the same way our launch file did it here. Okay, next, if you wants to visualize the joint state, where is the how many joints are there and its axis, you can find through the TF, and you have to add the TF at here. Okay, so we can find it, see that here is the TF of the joints. It can visualize the position and the angle of the rotation. If the roll will move, it will also, the TF also be rotate. Okay, by the example you can see. Here you can observe that TF also is rotating. The red color which we are seeing, if the joints are rotating, so it is also rotating, and it will show the position also. In this way TF will help us where the joints are located. Okay, just I have stopped the running. Next, if you have a camera to the rover and if you want to see the world, so what option we have to enable? First of all, you have to select the camera. In this camera you have to select the topic. Here is the raw image and normal image, which can show you the depth of the world, depth of the on objects, and there are the two topics that we can see here, a raw image and the depth image. Okay, through the raw image you can see the world in this way. If you place any object in front of the rover, you can visualize in front in this camera. Did you get it? And there is a number of, like you have to see the depth, how much you can increase the 10. Okay, you can increase the 100, you can see here. And that too, if you want to zoom the cam, so you can increase the value. So here the camera is zoom in. So if you decrease the value, the camera will be zoom out in this way. Okay, so like some situation will be make us to zoom the camera based on the situation. Like if the thief is going fast, we have to zoom the camera. By the situation, based on the application, we can decide the how to visualize the object. Okay, in this way we can use this camera. And next, this rover is for the autonomous navigation purpose. So if there are any obstacles, so we have to visualize the obstacle in the rviz. So we have to use laser scan. Through the laser scan we can visualize the what are the obstacles surrounded us. So we can see here, this is the red box we placed at here. Okay, it is visualizing the rviz. If you want to see more accurately with high intensity, you can increase the number. So you can see here the more pixels we are seeing there. If you want to reduce the size of the object, not an object, like visualization, you can 0.2. in this way you can keep. By seeing you can understand what I am doing. Next, these are the alpha. If you keep the 0.5, here is the intensity, you can reduce the laser. And by tuning the parameters, you can understand how the visualization will appear in the rviz. Based on our applications, we have to decide what type of visualization we have to see in the rviz. We can import it. And this is a grid. Already we have the grid by default, I think so. Yeah, here is the grid by default. Here I kept the grid according to the base frame. Like where is the rover will be moved, the grid will be moved there in that way. If the fixed frame is the camera, it will be in the camera position. Okay. If I keep the it's a map, it will go to the original position. Okay, this is the one thing. And that too, there are number of options like plane cell counts. Like if you increase the plane cell counts, it will increase the cells. Like you can see here, I am increasing the number of cell counts. Automatically it is increasing the cells in the x and y, like in area you can think. So it will helpful for us, like more in the mapping purpose. Mostly while we are doing the mapping to our surrounding, it is so helpful for us. We can increase more, but increasing the grids, it is makes a lag in the visualization because of number of data it's have to process. So just you can see here, if I can keep the 100, it's better to visualize, and the cursor is moving very slow, smooth. If you keep this is more than lakh, so it is so hard to see, and the processing also, so it is so lag. So if I increase so much, so like you can feel it is so hard, and it is not that much of better. Like based on your area you can select these cells, okay, and that too pixel count. This option will available like enable when you are working on the 3D 3 dimensions, like drones, and the drones will need a 3-dimension visualization. So you in that scenario you can do this, enable the option. You can increase based on the how much height you are working. If the drones will be in high, like work on some x distance from the ground, you can increase that much of cells. Based on your axis you can change the direction also. Coming to the, here is the cell size. You can see here each cell, wait a minute, I will keep it as 0, you can understand very well. 0, here is a 1. Here you can see the each cell is 1 meter, 1 square meter, and if you want to increase the size of the cell, you can easily change the number, it will directly increase the size, but it is not an accurate for the navigation purpose. In navigation we can we need a very small cell which can accurately useful for the navigation, like shortest path distance. So that's the reason we can keep very little cells, like very little meter below the meter. Based on the rover we can decide the cells also. If the our rover is belongs to size of 1 meter, and we can keep the cells nearest to half meter range. If our rover size is only half meter, we can decrease the less cell, like area square meter is less. So in the navigation purpose it is so helpful for us, okay. And there are many options based on situation, you can use it like a plain, alpha, and if I keep the alpha you can see the intensity is increasing, okay, the line intensity. And the offset, like if you can see here plane, it is the xy plane, and you can change it into the, this is the xz, okay, like z is in the top and x is the horizontally, you can see here this is the x and this is the z, okay. So by changing you can see z is always at the top, and y is the you can see the in 3D it is a depth, okay. Here is the offset. Offset is nothing but the where this grid should be located based on if you can change the number, it will locate, it will change the position, okay. In x axis it will be move. If you change more 16, it will change more, like it will go back of the rover. So in this way you can modify the options in the grid based on your application need, you can do the modification. Next, here you can see the already I have first cell. Based on the frame, fixed frame, you will see the how visualization, where it should be move the rover or it should be move the map, okay. And that too you can see your colorful wall by changing the background, like green, purple, yellow, green, okay. By changing color we can see. And here is that fixed rate, frame rate. If you increase the frame rate, then you can smoothly see the motion of your visualization. Okay, here you can see the very smooth motion. If you keep here like 100, it will be the frame rate for second 100 frames, it will, we can see very smoothly. Okay, if you keep only one, then it for second it will show only one frame. Okay, so it is so lag, we can see here. Did you understand what is the frame rate? Okay, next, up to here we can understand the laser, and through laser we can see the obstacles, and there is a topic names. Through the topic names we can subscribe the data and visualize in the rviz. Okay, there are the many options we can see here, the depth of how much we can see, and the style, we can change the style of the obstacle, how we can see like a square or box. Okay, in that way the it will be modified, and I will modify this up to 100. Okay, next, and here is the move camera based on the position. If you click the cursor at here, it will locate at there, and we can easily zoom it. If you want to locate the frame at here, so we can take a cursor and put it here, we can see here. Okay, like if you want to see the object in this corner, just click on here, the camera will focus on here. After that you can see. Okay, next, through this we can select the objects. So in this way we can select the objects and see the rover. Next, focus point. The focus point, if you want to focus a particular place in the rviz, just click on there, it will automatically move the cam. Next, measure. This measure will useful to the, if there is any two different objects in the rviz, like we can calculate the distance between the two objects. Like here to here, you can directly, here you can't see the line, like here you can see the black line which can measure the distance between them two objects. It is useful for that. And the 2D pose estimation, it is useful for the navigation purpose, where the initial position of your rover should be, and based on that it how to move to the goal location. And in this way, if the rover is at here, if you wants to change the initial position, just you can right click at here, it will automatically change the place. Just I am saying, I am not doing the navigation part at here. And right now this is the 2D goal pose. After if you wants to go to a particular location in the map, it will very useful for you. Just select the position in your map, just right click, it will directly initialize your goal position and publish the points. And these published points will helpful to you if you wants to go to the number of places in sequential order. So first of all you have to mark the places, like first this, second this, like first this, second this, third this. So it will follow the points. For that purpose it will very useful for that. In this way we can use these options. And next, view purpose, we can see the orbital view and third person following view. We can change the fixed frame also, like a base link. What you can see here, the based on the, if you keep the base link, it is adjusting to the base. If you keep the LiDAR, it will adjust to the LiDAR. If you keep the some else, just a small changes it's going on, that is not a problem. Okay, and the main thing is you have to see the time at here. This is the ROS time, and this is the here you can see the in the seconds, like 620. So this is the wall time, wall expected. In this way you can see, if you wants to reset the time, here is the button to reset. Okay, in this way you can visualize the your robot data in the rviz, and there are many options, like point cloud and point cloud to to visualize the depth of the image. In this way we can use that, and the odometry. This odometry is useful to the where the according to this rover, where the rover is there and how much is distance travel. Through the odometry data we can see this. For each and every second the odometry will be updated, and marker array, and by using the marker array we can directly interact with the objects in the rviz. So based on that we can use the marker array. And coming to the map, map is very useful for the navigation purpose, so we can easily see the our surrounding area in the map, and through the map we can do the waypoint navigation. And coming to the laser, already I have said before, here is the image, this is also I said before. Coming to the, there is a pose array, its position, we can say that in the form of many arrays it can show the position. Okay, there are different types of, and the temperature, and by topic means if you wants to publish a specific topic from externally, you can directly use this. Rather than this you can use this also, like afford, odometry, laser scan. Already this is also available, and here also in like initial pose. These are the topics if you want to subscribe from externally. Okay, depth cloud, everything. And is there any remaining? That's it. And this is the use case I use in this rviz. Based on my application, I use the rviz in this way. So beyond my application, I think I said how to use the rviz, and there are many cases. It will helpful to you, I think, in this video. Thank you.